In this video, we're going to review adding and subtracting mixed numbers using both improper fractions and mixed numbers. Please go to the bottom of page 88 in your student journal and fill in these problems as we go through them. The first one we're going to start with is A, and we're going to be adding 1 1/4 plus 2 1/3 using improper fractions. So we remember that when we change mixed numbers to improper fractions, we multiply the base of the fraction times the whole number, and then add the numerator. So 4 times 1 is 4, plus 1 is 5. So I have 5/4 plus 3 times 2 is 6, plus 1 is 7, 7/3. Now, as you know, we have to find a common denominator when we do this. So my common denominator for 4 and 3 is 12. My lowest common denominator is 12. So I'm going to write my denominator as 12 for each. I know that I have to multiply 5/4 by 3 over 3. Which makes it 15/12. And I have to multiply 7/3 by 4 over 4, which makes it 28/12. As I add this, I keep the denominator the same, and I add my numerators. 15 plus 28 is 43, and I have 43/12. Now, when you change mixed numbers to improper fractions, oftentimes, if you're adding, what's going to happen is at the end, you're going to have to change the improper fraction back to a mixed number. So I have 43/12. I can either do this in my head. I can say 12 goes into 43, 3 whole times, that's 36. And then there are 7 left over out of the 12. If we don't remember how to do this, we can use Tae-Bo. We can put the top in and the bottom out. We say 12 goes into 43 3 times. That's 36. When you subtract, you get 7, and then there is your mixed number. 3 whole times with 7 left over out of 12. You do have to make sure that when you're done, that the proper fraction part of the mixed number is totally reduced. 7/12 is totally reduced, so you're good to go. Now what you're going to find when you solve the problem using mixed numbers is you have to end up with the exact same answer. So if you have 1 1/4 plus 2 1/3, you are going to find a common denominator, keeping it mixed numbers. It's still going to be 12, so I write them as 1 and something over 12. Plus 2 and something over 12. 4 times 3 was 12, so 1 times 3 is 3. 3 times 4 is 12, so 1 times 4 is 4. Now when you add these, you add your whole numbers, which is 3, and then add your numerators, which is 7 out of 12. And you reach that answer right away. You know that your problem is right because both of the problems turned out to be 3 7/12. So try the second one on your own and come back and watch the video. See how you did. Okay, let's see how you did. When you changed 2 1/3 to an improper fraction, 3 times 2 is 6, plus 1 is 7, so you have 7/3. And 5 times 3 is 15, plus 2 is 17/5. I find my lowest common denominator for 3 and 5, and the lowest common denominator is going to be 15, so I'm changing them both to 15. 3 times 5 was 15, so 7 times 5 is 35. 5 times 3 was 15. 3 times 17 is 51. When I add those together, I get 86/15. So now I need to know how many times 15 goes into 86. Another strategy you could use when you do this is to count by 15s. So 15 plus 15 is 30, plus 15 is 45, plus 15 is 60, plus 15 is 75. And if I add another 15, I'm going to get to 90. So when I count them, I had 1, 2, 3, 4, 5 15s got me to 75. So 5 whole 15s. And then if I take 75 away from 86, I get 11 15s. And when I check 11 15ths to see if it can be reduced, it can't be, so I know my answer is 5 and 11 15ths. When I look at mixed numbers, if I am going to add 2 1/3 plus 3 2/5, same common denominator, it's 15. I'm going to multiply 3 by 5, so 1 times 5 is 5. And I'm going to multiply 5 times 3, so 2 times 3 is 6. When I add 2 and 3, I get 5. And 5 plus 6 is 11 15ths. And I see that I have the same answer, so I know that mine are right. In the end, you're going to choose which way is best for you as far as solving, adding and subtracting mixed numbers. You can either always change them to improper fractions or always change them to mixed numbers. Either way will work. All right, let's switch to page 136. This time we're going to be subtracting the same way. Let's do the first one together and you can try the next one on your own. 3 times 3 is 9, plus 1 is 10/3, minus 4 times 1 is 4, plus 1 is 5/4. Common denominator for 3 and 4 is 12. 3 times 4 over 4. 3 times 4 is 12. 10 times 4 is 40. 4 times 3. So 5 times 3 is 15. I take 40 minus 15, I get 25 over 12. I'm counting by 12s. It goes 2 whole times, which is 24. So there's 1 left over out of 12. 2 and 1/12, and that cannot be reduced. If I change this, or keep them mixed numbers, so I have 3 and 1/3, minus 1 and 1/4, I still have 12 as my common denominator. I'm going to multiply 1/3 by 4 over 4. That gives me a numerator of 4 because 1 times 4 is 4. I'm going to multiply 1/4 by 3 over 3. Gives me a numerator of 3. And I get 2. 4 minus 3 is 1/12. 2 and 1/12 for both of them, so we know that we're correct. All right, you try the next one, see how you do, and then we'll be done. Okay, so 6 times 2 is 12, plus 4 is 16, so I have 16/6, minus 5 times 1 is 5, plus 2 is 7/5. My common denominator is going to be 30. So 6 times 5 is 30, so I'm going to multiply this by 5 over 5. 16 times 5 is 80. 5 times 6 is 30, so I'm going to multiply this one by 6 over 6. 7 times 6 is 42. When I subtract, I get 38 thirtieths. So looking at 38 thirtieths, I see it goes in one time. I have 8 left over out of 30. And this time I can actually reduce. So I'm going to divide by 2 over 2. And I get 1. Now you notice the whole number doesn't change. And 4/15. Okay, so 1 and 4/15. Let's see how we did with mixed numbers. You had 2 and 4/6 minus 1 and 2/5. Keeping it the same, 2 and something over 30 minus 1 and something over 30. Multiply this by 5 over 5. I get 20 thirtieths. And multiply this by 6 over 6. And I get 12 thirtieths. When I take 2 minus 1, I get 1. 20 minus 12, I get 8 thirtieths again. Divide by 2 over 2. And I get 1 and 4/15. Same answer for both of them. This time you had some reducing, so at least we had a little bit of a change in that one. Now I want you to think about how all of these kind of turned out nice when you did them. Only one of them had to be reduced when you were done. You have to realize that oftentimes you're going to have to reduce at the end. And oftentimes when you add, if you keep them mixed numbers, they're going to end up mixed improper, which needs to be fixed. Or when you're subtracting and you're using mixed numbers, sometimes, let's say we look at this bottom right here when we get to the subtraction, sometimes if you look at the 20 and the 12, sometimes the 12 will be bigger than the number you're subtracting from, and you're going to end up having to borrow from the whole number. Now that's not going to happen in this lesson, but our next lesson is going to show you how to take care of that. So take your time, solve them both ways, make sure your answer is in the most simplified form. Okay, good luck.